In this example, we're given two functions and asked to perform an operation on the functions and then state the domain. So we have f of x equals x squared minus x minus 4 and g of x equals 2x minus 6. And we're asked to find f over g of x. Well, f over g of x is really the same thing as f of x divided by g of x. So in this case, f of x equals x squared minus x minus 4, and g of x is equal to 2x minus 6. Now, in the numerator, notice x squared minus x minus 4 cannot be factored, so therefore we cannot simplify this rational expression at all. So f over g of x is simply x squared minus x minus 4 all over 2x minus 6. Now how about the domain of this new function? Well, in order to figure out the domain, we need to note that we have a rational expression. So the domain is going to be any real number except a number that makes the denominator 0. So let's find out what makes the denominator 0 by setting the denominator equal to 0. So let's set 2x minus 6 equal to 0, and we get 2x equals 6 or x equals 3. Now remember, this value x equals 3 is the only number that is not in the domain. So we're ready to state our domain. So our domain is the set of all x such that x is not equal to 3. This is our domain written in set notation. A lot of times we write the domain in interval notation, so I'm going to do that as well so you're familiar with both of them. So we want any value of x except 3. So we can write that as negative infinity, comma, 3 on an open interval, union 3, comma, positive infinity. And what this means, negative infinity to 3 really means all real numbers or all reals that are less than 3, but it does not include 3. Union, the 3 to positive infinity, really means all real numbers or all reals greater than 3. So either way, if we write it in set notation or in interval notation, either way expresses the domain of our rational function.